Yes, ma'am, you are audible.
Dear professors, sorry for the inconvenience. Okay. In the morning session, we have discussed about classification performance measures like precision, accuracy, recall, and the FN score. And also we have discussed various topics like perceptron, what is perceptron, and what is a class validation, what are the advantages and disadvantages of using class validation methodology, and also what is bootstrapping, and where has been used, what are the advantages and the disadvantages and the limitations of bootstrapping. So these things we have discussed in the morning session. Now we have start from neural networks. Okay, so neural network. So it is a machine learning algorithm or a model that makes a decision in a manner similar to the human brain. So, so we can say it as it is a computational model inspired by the human brain's structure and function. It is mainly used or it is mainly designed to recognize patterns and also make decisions, used to predict outcomes, to predict the outcomes based on the data. So we can say it as it is a subset of machine learning algorithm also. So what are the structure of neural networks? And now we have to discuss about what are the main components or structure of a neural networks. So we have a three important layer, the neural networks. First one is can you understand what is a neural network? So it is the subset of machine learning algorithm, and we can say it as a computational model inspired by the human brain structure and the function. How the human brain, and the human brain are related with the neurons. So in the same structure and the function will be followed in the neural network concept. So basic structure of a neural network is so, and also we can is mainly used for to recognize the patterns, predict outcomes based on the given data set, and also we can make a decision based on the data set. So next we have seen basic structure of neural networks. So the neural network have three important layers like input layer, hidden layer, and the output layer. So this is the input layer. Here, the input layer consists of more number of nodes. Here, each and every node is associated with the features. Next one is the hidden layers. Finally, we have the output layers. The input layer process take some input features for processing. Then it will send the data. So after processing the data, it will send to the hidden layers. Finally, from the output of the hidden layers, data will send to the output layer to get the final output. So these are the important structure of neural networks. So the input layer. The first layer is the input layer here, where the data is feed into the network. Here, each node in this layer represents the input feature. already I have told each and every node, each first node will have a one feature, second node will have another feature. So each and every node will specify separate feature. Next one is the second layer, is the hidden layer. This layer perform most of the computation. Mainly it is used for a computation through multiple interconnected neurons, because and also the network can have multiple hidden layers. It is not mandatory to have only one hidden layer in a neural network. It is a they have multiple hidden layers, so it allowed to model complex tasks. If we take a data set as a complex one, so our complex model we are going to handle means we can have multiple hidden layers based on the data set. Next one is the output layer, the final layer that produces the result. So this is the final layer, which would be class label or a continuous value. So the value will be a continuous manner or a classification manner. So based upon the data set or based on the need, we will get the output. So here each neuron in the layer connects to the neuron in the next layer. So we have some neurons or a node in the input layer, and also we have a set of nodes in the hidden layer. So here the node in the input layer will be connected to neurons in the hidden layer, which with each connection having a weight that adjusts during training to minimize the error. Here, neurons are activated based on weighted inputs in the activation function, which add a non-linearity. So next, here, how the neural network works. Consider a neural network for a image classification. Always we are using the scenario like email classification. So the same scenario will be taken for a neural network working procedure. Here the input layer take features like email content, centered information, and the subject of a particular mail. So these are the important feature of the email, important inputs of a email. So we will consider this input as the features. So these inputs multiplied by adjusted weights, and it will be passed through the hidden layers. So now in the input layer, just we can pass the input features, and then we can add some adjusted weight to the features, and then we will send to the hidden layers. The network, through training, learns to recognize patterns indicating whether an email is spam or not. So the output layer, the binary activation function used to predict whether the email is spam or not. And also, as the network refines its weight through back propagation, it becomes adept at distinguishing between the spam and the emails. And also, it showcase the practicality of neural networks in real-world application like email filtering. So now we will discuss how it was work. So we have several steps how it was working. The working procedure of a neural networks may involve several steps, from the data input to the model prediction. So first important step is the input layer. The neural networks receive the data through the input layer, which is which a neuron represents one feature of the input data. Already you know that. For example, if we have a image, we are going to perform the image processing task. So in that, each node might represent a pixels intensity of an image. So here we are going to take a pixel intensity as a feature. Next one is the weight and bias. Here each connection So here each connection between the neuron is associated with a weight, which represents the importance of input feature for the task. Initially, the weights are set randomly and biases that are added to help the neural network to learn the complex pattern. So first, we are going to add neurons and the weight to the weights are set randomly to the input feature for helping the network learn network complex patterns. Next one is the forward propagation. So it is the process of passing the input data through the network layers. So in this, we have two methods we can follow. One is the linear transformation and another one is the activation function. In a linear transformation, the input feature are multiplied by their respective weights and their bias is added to produce a weighted sum. Already we have discussed the same part in the perceptron. The same things we have discussed in the perceptron also. The input features are multiplied with the respective weights. Finally, the bias will be added to produce a weighted sum. Have you recall it? The same concept we discussed with the perceptron also. So this is the linear transformation. So next one is the activation function. So these two methods are used in the forward propagation. So this is the important process. It's the process of passing the input data through the network layers. So linear transformation, you know what is linear transformation. So next one is the activation function. Here in activation function, each neuron applies the activation function to the weighted sum. So this function add nonlinearity, enabling the network to model complex relationship. The output of each layer becomes the input to the next layer, propagating forward until it reaches the output layer. So finally, we have the output layer. In the output layer, network produces its final result. The form of the result depends on the type of the task. So what type of task or what type of model or a data set we are going to handle. So based on that, we will get the final result. Because for a classification task, the output layer may use a softmax function, producing probabilities for each class. So here, in the classification task, we should use the softmax function. Next one is the regression. Regression task, the output might be a single continuous value. Okay, can you understand? Because a regression output may be a continuous value. Classification, always it is a categorical or a based on two classes. So that only for classification task we are using softmax function producing to identify the probability of the each class. So finally, next one, loss function. So the network's prediction is compared to the actual target using a loss function. So the loss function is also known as the cost function. It is the network prediction is compared to the actual target. The loss function is made to compare the actual target and the prediction target. So the loss function quantifies how far off the prediction is from the true value. For example, mean squared error. So this is commonly used for regression, and one is the cross entropy loss. So this is one of the methodology which is used for classification task. So loss function is mainly used to compare the actual target with the prediction value. So these things will be discussed here. Last calculation, the network's output is evaluated against the real pool values, and the loss function is used to compute the difference. So the last function or cost function. Cost function is also known as the cost function. Here, mean squared error. So mean squared error is the methodology based on loss function, which is used for a regression. Like here, if the task is a regression, we can use the mean squared error loss function. Next one is the classification task. For a classification task, we can use cross entropy loss function. Next one is the back propagation and the gradient descent. So this is the important part where the network we are going to learn. First one is the back propagation. So the network calculate the gradients of loss with respect to each weight by moving backward through the network layers. This process identify how much weight contributed to the error. So this is the back propagation. So next we will discuss how the back propagation steps are going on. So once again I repeat. So back propagation is used to identify how much weight contributed to the error. So this is the concept behind another back propagation. How much of weight each weight contributed. Maybe when we are performing a task, maybe chance to occur error. So this process we can use the back propagation process to identify how much each weight will contribute to the error. So next one is the gradient descent. So using this calculated gradients, the network adjusts the weight to minimize the loss. So gradient descent mainly support to minimize the loss, because we can identify the how much of weight will contribute to the error by using the back propagation methods, and after that we can adjust the weight. So what are all the weights are participated in that, we can identify the back propagation. After that we can adjust the weight to minimize the loss. So these are the important parts of the neural networks. That is back propagation, loss calculation, and a gradient descent. So next one is the final step is the training process. So in that we have to discuss now how the back propagation algorithm working. First, we can take the number of inputs as X that will arrive through the pre-connected path. This is the first step of the back propagation algorithm. Then we can model the input using true weight that is denoted as W. So we can model the input functions or input futures to the weight that will be called as W. And after calculating, we can choose the values randomly. So this is the step 2. After that, step 3, we can, in this step, we can calculate the output of each neuron from the input layer to the hidden layer to the output layer. After that, we can calculate the errors in the outputs. So in the step 3, we can calculate the output starting from input layer. Then output of the input layer will send to the hidden layer. Then the output of the hidden layer will send to the output layer. Finally, we will get the final result from the output layer. After that, we can calculate the error in the outputs. So the propagation error will be calculated from actual output, the difference between the actual output and the desired output. So from the output layer, we can go back to the hidden layer to adjust the weight to reduce the error. So that is called the back propagation. So only this algorithm will be called as a back propagation, because we can identify the errors or a loss from the output layer. Then we will go back to the hidden layer from the output layer to adjust the weight of each weight to reduce the error. So this process will be repeated until the desired output is achieved. So these are the steps involved in the propagation algorithm. Can you understand? So first we will get the input that is denoted as X. Then we have to calculate the weighted sum. That means we can multiply the input futures into the weight. After that, we can add the bias so that we will get the weighted sum in the input layer. After calculating the weighted sum, we will send the inputs to the hidden. After that, it will send to the output layer to get the final result of the data set. Then from that, we can calculate the error in the output. So the propagation error will be calculated as actual output minus desired output. From the output layer, we can reduce the error by send back to the hidden layers to adjust the weights of a node to reduce. So this will help us to reduce the error. So this process will be repeated until the desired output is achieved. So these are the important steps to be followed in neural networks. So next one is the types of neural networks. Totally we have 7 types in neural networks. First one is the feed-forward networks, multi-layer perceptron, convolutional neural network, recurrent neural networks, short-term memory. So these are the important types of neural networks. So first one is the feed-forward neural network. So the feed-forward neural network is a artificial neural network in which data moves from input to output in a single direction. So it has input layer, hidden layer, and output layers. Feedback loops are absent. Here, we cannot resolve the error by using the hidden layers, because generally in neural networks we have discussed if the error happen in the output, we can go back and we can adjust the weight to reduce the error. So these are the things we have discussed. But in the feed forward networks, feedback loops are absent. That means we cannot go back to solve the error. So it's a straightforward architecture, makes it appropriate for a number of applications such as regression and pattern recognition. So next one is the multi-layer perceptron. So multi-layer perceptron is one type of feed-forward neural networks with 3 or more layers. Basically, it includes input layer, hidden layers, and output layers, and also it uses non-linear activation functions. So multi-layer perceptron is one type of feed-forward layer. So in multi-layer perceptron, we does not have a feedback layer. Next one is the convolutional neural network. So it is mainly designed for image processing and the visual task. Convolutional neural networks, that is a CNN, we can say it as a CNN, that is a convolutional neural networks. It is mainly designed for image processing and visual task. CNN use a convolutional layer to automatically and efficiently learn spatial hierarchies in an image. So we can easily identify the space in the image. It employs convolutional layers to automatically learn hierarchical features from input images so that enable effective image recognition and classification. So it have a revolutionized computer vision, uh, and also it is mainly used to detect objects and image analysis. So convolutional neural networks is mainly used for image analysis. So next one is the recurrent neural networks. So this is one type of a neural network. It is mainly used for sequential data processing, and it is appropriate for applications where contextual dependencies are critical, such as time series prediction and natural language processing. So recurrent neural networks mainly used for NLP and time series prediction, since it makes the use of feedback loops which enable information to survive within the networks. Next one is the long short-term memory. So this type of recurrent neural network is designed to overcome the great problem in training RNN. It uses memory cells and aggregates to selectively read, write, and erase the information. So long short-term memory. So this is a one type of RNN. This is not a neural net type of a neural network. One type of recurrent neural network. So generative adversary networks. So it is mainly used to competing networks, a generator and a discriminator. So if we have a generator network and the discriminator networks, to competing these two networks, we can use generative networks. So this is mainly used for tasks that involve generating new data samples like image synthesis. So for synthesizing synthesis image, we can go for a generative adversarial neural networks. So these are the types of neural networks we have discussed this session. So first one is the feed-forward neural networks, and the next one is the convolutional recurrent neural networks, generative adversarial networks. So feed-forward neural networks. In this type of network, data flow will happen in only one direction. That means from input to output. After getting the output, we cannot identify the error and go back to the hidden layers. So the data flow feed-forward neural networks means the data flow will be from one direction to only one direction. That means from input layer to hidden layer to output layer. That's all. There is no backward from output layer to the hidden layer. It is not applicable in the feed-forward neural networks. So this is mainly useful for basic tasks like classification and regression. So classification and regression are the types of supervised learning. So next one is the convolutional neural networks. So convolutional neural networks is mainly designed for image processing. Next one is the recurrent neural network. So this is mainly suitable for natural language processing and also time series forecasting. Finally, we have seen that generative adversarial networks is mainly used for image synthesis. So these are the simple tips for keep in mind of types of neural networks. Next, we have seen the advantages of neural networks. So, what are the advantages?
45. 245.
Adaptability, pattern recognition, and parallel processing, and also non-linearity. So, adaptability, it describes that the neural network provide and support in all the situation, and we can learn more things from the data set. Next one, the pattern recognition. It is mainly used for image identification, natural language processing. Yes, sir. Sujita ma'am. Sujita ma'am. Can you mute your audio? Sujita ma'am. Ma'am, can you? So these are the advantages of the neural networks: adaptability, adaptability. Next one is the pattern recognition. So pattern recognition supports like audio and image identification, neural natural language processing, and also various data pattern. Next one is the parallel processing. So it can process numerous jobs at once, which speed up and improve the efficiency of the computation. That means it will support a more number of processes at a time, and also the efficiency will be also good. Next one is the non-linearity. So neural networks are able to model and comprehend complicated relationship in data. So next one, what are the limits of a neural networks? Here the neural networks while powerful, are not without drawbacks and difficulties. It does not have any concepts without the drawbacks and difficulties. So computational intensity. A large neural network training can be a laborious, demands a lot of computing power. And also black box nature. Yes, black box models, it is difficult to understand how they make decisions, because it was this concepts will comes under why it comes means because of the hidden layers. Because in the black box we cannot predict what happening there behind that. So that the hidden layer also the same thing happening. So it follow, we can say it as it follow the black box nature. Next one is the overfitting. So this is the phenomenon in which neural networks commit training material to memory. And also it need large data set. For efficient training, neural networks frequently need sizable and labeled data set. Otherwise, their performance and the accuracy may suffer from incomplete data. So, for efficient training, it need the size will be comfortable. Then we can easily we can easily go with the performance, and we easily calculate the efficiency and the performance matrix. So if the data set may be a large, so it is very difficult, and we will be in the position of incomplete data. Next one, multi-layered feed-forward neural networks. So incoming data is routed multi-layer feed-forward neural networks. So here, the incoming data is routed through several layers of artificial neurons. Here, every node is linked. Here, you can see this diagram. You can refer this diagram. That means here, every node will be connected to next node of the layer. Every node is linked to every neuron in the following layers. Something in a fully connected neural networks. Here the node is connected through neurons. So this node input layer, we can consider one node or a node in the input layer, and then we can consider another node in the hidden layer. Here the nodes are connected neurons, so that it is a fully connected neural networks. There are the input and output layers as well as several hidden layers for the total of at least 3 or more layers. It processes a bidirectional propagation, which means it can propagate both the forward and backward. And also here, the inputs are multiplied by the weights and is applied into the activation function. The inputs are multiplied by the weights and added with the bias for calculating the weighted sum, and then supplied into the activation function, where they are adjusted to minimize the loss during backpropagation. Here the weights are just machine-learned values for the neural networks. So in multi-layer feed-forward neural networks, softmax function will be used. So this is the concept is used as an output layer activation function after nonlinear activation functions. Finally, the feed-forward neural networks are sometimes referred to as multi-layer networks of neurons. This information only flows forward in the neural networks. First, the input nodes, then first through the input nodes, and from the input nodes to the hidden layers, and from the hidden layers to the output layer. So this is this network of model is termed as feed-forward. Can you understand? The feed-forward neural networks are referred to as the multi-layered networks of neurons. Here, the flow will be in only one side. That means the flow forward, the neural flow, the flow will be only from input to hidden layers to the output layers. Finally, we will get the final, after that, we will get the final result. Excuse me. Then we will get the final output. That's why this network of model is termed as feed-forward, because it does not allow go back. We cannot go back from output layer to the hidden layer. So only this will happen from one way. And this will happen in one way. That is forward only. So it is called a feed-forward neural networks. Next one, we should know, we have discussed activation function. The activation function is calculated based on the weighted sum and the bias. But we should know really what is the activation function. So this is the context of a neural networks in a mathematical function applied to the output of a neuron. The purpose of an activation function is to introduce a non-linearity into the model allowing the network to learn and to represent complex pattern of the data in the data. So activation functions, so we can know that it is a mathematical function. We can apply to each neuron's output to introduce non-linearity into the network. So the non-linearity is essential in a model, because without it, a neural network with any number of layers would behave like a single layer linear model. So it limits its ability to the model complex relationship. And also activation function help neural networks to capture patterns in the data, and also enable them to perform well on a wide range of tasks, from image recognition to natural language processing. So we have a variety of activation functions, and the most commonly used activation functions in neural networks are sigmoid activation function, hyperbolic tangent, rectifier linear unit, and a softmax function. So most commonly used activation functions are sigmoid function and a tang activation function. That means hyperbolic tangent. Hyperbolic tangent. Next one is the ReLU, that is rectified linear unit activation function. Activation function. So next one is the Leaky activation function, parametric activation function. Finally, so these are comes under the type of rectified linear unit. That means rectified linear unit have a subdivision of leaky and parametric methods. Finally, we have a softmax activation function. So these are the some functions used in neural networks. So sigmoid activation function used to plot the output in the range of 0 and 1, range from 0 and 1, and it make very useful for binary classification task. This function is smooth and also very smooth and has a clear gradient, but sometimes it does not have a back propagation, and also it will going slow down in performing the model. So next one is the tang activation function, that is a hyperbolic tangent. So this type of activation function is similar to sigmoid, but the output values lies between -1 and the range between -1 and 1. And also it very helpful with the faster convergence, because it's a zero centered. That means positive and negative inputs are represented better. So it is we will get the positive values as well as the negative values. Positive and the negative inputs are represented better. So it is it is called as the zero centered, and also so that we will get the output as faster by using this activation function. Next one is the rectifier, that is RELU, rectifier linear unit, rectified linear unit. So this is one of the most widely used activation function in the hidden layers. It provides a sparse activation. That means the neurons are only activated if the output is positive. So this is the main important point in the rectified linear unit. Okay, can you understand? Rectified linear unit means the neurons are only the neurons which is present in the hidden layers are activated only if the output is positive. which reduces computational overhead. So these type of this activation function will be used mostly in the hidden layers. Next one is the softmax activation function. Here the output sum to 1 across all neurons. The main characteristics of the softmax activation function is the rightly used in output layer converts the output into probabilistic for each class, make it easier to interpret as class predictions. So these are the important functions: sigmoid, tank, ReLU, and then softmax functions. So these are the important function. In this, ReLU function is most widely used function of the activation functions. So this has been. So these things are discussed. So in this sigmoid function, so in this tank, so this activation function, it is mainly used for non-linear, which means we can easily back propagate the errors and have multiple layers of neurons being activated by the ReLU functions. The main use of the ReLU is a less computationally expensive than tank and sigmoid. It involves simpler mathematical operations at a time. Only a few neurons are activated, making the networks fast, making it efficient and easy for computation. Much faster than sigmoid and tank functions. So these are the main things and the main advantages of why we are go for ReLU function frequently. So these are the activation function. So we'll recall what is networks, what is neural network, and what are the types of neural networks. So once again, we will recall. So neural network in a machine learning model, it makes a decision similar to the human brain. So how our brains are working with the neurons. So in the same way, the neural networks. So it have a combination of human brain structure and the function. அங்கே கொடுத்துருக்காங்க. So neural networks are computational models inspired by the human brain structure and the function. So it is a subset of machine learning algorithm. Neural networks is nothing but is a subset of machine learning algorithm, and also it is a part of artificial intelligence. Next one, what are the basic structure of neural networks? What are the basic structure of neural networks or basic components of neural networks? We have three important layers neural networks. First one is the input layer. 90. So we have an input layer, hidden layer, and output layer. The input layer is the first layer of a neural network. Each node in this layer represents the input feature. Next one is the hidden layer and the output layer. So these are the important components of neural networks. Here, every layer have nodes. So the circle represents the node. That means the input feature. Here, the node of the input layer represents the input features. Every input features will be considered as a node. If the output of any, and also we have a multiple nodes in a hidden layers and multiple nodes in a output layer. And each and every layer, each and every node in the layers are connected with the neurons to give the root structure. Here, each and every node connect to the associated weight and threshold. If the output of any individual node is specified threshold value, the node is activated, sending data to the next layer of the networks. Otherwise, no data is passed on to the next layer of the networks. So neural networks, we have discussed how the neural networks are work. So these are the important components or a structure of the neural networks. So now we have discussed the components and the types of neural networks. We have several types of neural networks. That is a feed-forward network. It is important in this. We have only we have in this type of network, the data moves from input to output. That means we have only single direction. So it will be called as the feed-forward network. Another type of network is a multi-layer perceptron. This is a one type of feed-forward neural networks, and also it have a 3 layers. Includes input layer, hidden layers, and output layers. And also it is mainly used for non-linear activation functions. Next one is the convolutional neural networks. Design and image classification. So these purpose image analysis or object detection. So for whatever it is related to image, we can go for a convolutional neural networks. Next one is the recurrent neural networks. This is also important type of neural network. So in recurrent neural networks, see, this is mainly used for series prediction and NLP. In this, we can make use of the feedback loops. So from the output final result, if we have a more, if we find a more number of errors, means we will have an recurrent neural networks. So in this, finally we have a long short-term memory. So this is a one type of recurrent neural networks. So recurrent neural networks, convolutional neural networks, and the feed-forward neural networks. So these are the important type of neural networks. In this, which is the best one means the best type of neural networks. We can say it as a specific application or a task at hand. Here, if we want to, if we have a data set like image, we can use the convolutional neural networks, because image recognition, or a image analysis, we can use a convolutional neural networks, because it is specifically designed to handle grid-like data. Grid-like data means images. Okay, CNN is specifically designed. We cannot say this one is this type of neural network is good. This type of neural network is not good. We cannot say like that, because each and every type is designed for a specific purpose. So if we go for a image analysis, CNN can be used, because it is used to handle grid-like data. That means for images. So it can automatically capture spatial and hierarchical features within the images. So it is mainly used to the spatial points or a pixel. We can use images. They use convolutional layers that efficiently recognize edges, shapes, textures, which makes CNN very effective for image classification or object detection and other vision related tasks. Next one is the recurrent neural networks. We cannot say recurrent. If we are going to take a data set that is a sequence data or a time series or a language modeling. So this type of concept, we can go RNN, because RNN are specially designed to handle sequential data. That means where data, each data point is related to the previous one. That is, this sequential data means already you know that every data point is related with the previous one. That data is related to previous one. So this is the sequential data. So if you want to handle a sequential data, we can use the RNN algorithms. So we have discussed the LSTM. So LSTM is the advanced form of a RNN. Okay, it is good for capturing long-term dependencies and information over extended sequences. They mainly use it for language modeling, vision translation, time series. So time series forecasting, automatically you can use a RNN. And also speech recognition. So this is the important another application of RNN, that is a speech recognition. So image, you can go for CNN, and a speech recognition or a time series forecasting or a machine translation or a NLP modeling. So for that, we can use a recurrent neural networks. So next we can discuss some real-time example of neural networks across various industries, where in an industry side, how neural networks support and what are the important points, important concepts they are, important types they are using. So these things now we will discuss now. So consider Facebook. Consider a Facebook account. So Facebook facial recognition. So in a social media, image recognition, we can find an image in a social media like Facebook or Instagram or WhatsApp. So whatever it is, in that we can want to recognize the image, we can use neural networks. So neural networks analyze uploaded photos. How it was work means, in social media, it analyze uploaded photos to detect and recognize faces, suggesting tags based on the identified faces. So in that image, can anyone say in social media, we want to recognize image, which type of neural networks can be used? Anyone? Because we have discussed the types of neural networks in few minutes before. So anyone can say for image recognition in anywhere, for an image recognition, what type of networks, what type of neural networks will support? No one is not ready to give me the answer. Professors? Professors, can you hear me? Can you hear me, professors? Anyone can say?
Yes, ma'am, we can hear you.
Sir, can you say me for image recognition, what type of neural networks will support? Muruganand Gopalraj, sir, can you tell me? Okay. Next one is the email spam. If we are go for a
CNN is used for image recognition, right? Widely CNNs are used.
CNN. Yes, sir. Yes, sir. Thank you, sir. Thank you for your reply. Thank you very much. So next one is the email spam. So in Gmail, we are going to detect whether particular mail is a spam or not. For that, we can use the neural networks. So neural networks classify emails as spam and also not spam based on their sender history and the user behavior. By training various data sets based on a mail, data sets of spam and non-spam messages, the network learns to recognize the patterns commonly associated with the spam emails. Next one, real-time language translation. Now, Google, sometimes we are going to use Google Translate's instant camera translation using a combination of CNNs for image processing and the recurrent neural networks for language modeling. The app detects text in an image, translate it, and overlay the translation of the screen. This happens in real time, allowing instant understanding in foreign environments. So, real-time language translation. That means we are going to speak something. The Google will translate into the text. Okay, the app directly text in an image and translate it. So, for these applications, neural networks will help. And also, self-driving cars. That means self-driving car means we can say it as an autonomous vehicle. So autonomous vehicle also use neural networks to process the data from cameras. Particularly, convolutional neural networks help identify the objects on the road like car, bike, road signals, any other things. So CNN mainly used to identify the object. And reinforcement learning models enable the vehicle to make the decision on speed, plan changes, and navigation in the real time. So it was implemented Tesla's autopilot. This is going on. Next one is the healthcare diagnosis and medical imaging. So even the neural networks will be very helpful in a healthcare and also medicals. So neural networks, if we are going to take a X-ray for some disease, the neural network processes the X-ray or a MRI or a CT scan to detect the abnormalities such as tumors, fractures, or a disease. So whatever it is, it will process the MRI scan or a CT scan. So it will detect the abnormalities. Then it will move faster and more accurately than the human experts, because a particular doctor will be an expert in a particular disease, so that identifying disease. But even though it will it will doing very fast than the doctors. So these networks assist radiologists in real-time diagnosis and decision making. The neural networks are very helpful. So these are the main areas of our application. So these are the advantages already we have discussed. Parallel processing. So so this is the important one, how neural networks approach the parallel processing and where it is used. Neural networks supports parallel processing, which is crucial for handling vast computations, especially for a large data set and deep architecture. So in these areas, neural networks supports the parallel processing. For example, matrix operations. So this is a very large task of operation. So in this, how neural networks, we will discuss how the neural networks will support. Neural networks heavily rely on matrix and vector operations such as multiplication, addition. Since each neuron in a layer performs a similar calculation, these operations can be parallelized across multiple processing units. Can you understand? Here, in an input layer, each neuron in a layer performs similar calculations. So these operations can be parallelized across multiple processing units. For that, next one is the parallel processing across neurons. In each layer of the neural networks, neurons can process their inputs independently. If we have a 5 neurons, means each and every neurons have a separate input features, so that neurons can process every node. So every node will be connected through neurons means here neurons can process their input independently from other neurons in the same layer. This independence allows parallel execution of neural calculation within the layer, with each neuron processing its input, apply weights, and performing activation functions simultaneously. Can you understand? That means sometimes what happening here means neuron processing. That is the input. We have a 3 layers: input, hidden layers, and the output layers. In this processing input, then applying weights, weight, and calculating weighted sum, calculating weighted sums. Finally, we will calculate the activation functions. So these things will happening in a parallel manner. So this approach significantly accelerate computations, especially in networks with many neurons per layer. And also parallel processing will help for convolutional neural network. We will discuss now how parallel processing will be supported in a convolutional neural networks. CNN perform convolutions independently over different parts of an image, because it will be taking an pixel by pixel for an processing, so that it will performing their task independently. So CNN perform convolutions independently, so that it is very supportable and making them highly suitable for parallelization. Here, each kernel Each kernel means that each pixels can process different image patches concurrently, taking advantage of parallel processing for both the kernel operations and individual filter applications. This leads to faster image processing and feature extraction. So that this parallel processing in a convolutional neural networks will mainly support for faster image processing and feature extraction. And the parallelization. So these are the main benefits of parallel processing is it will support speed. That means parallel processing significantly reduces training time, which is critical of real-time applications, and also scalability and also efficiency. So it is mainly used in parallel processing also. That is a batch processing. During training, the data is often divided into mini batches because we are going to take a large data set. It is not possible to apply a algorithm to a large data set, and we cannot get the level of we cannot get the proper level of accuracy. So that in the training time, the data is often divided into mini batches so that each batch can be processed in a parallel. This approach reduces memory usage and enable efficient calculation. It will take to the efficient calculation. Parallel batch processing also allows the network to process large data set more quickly, as batch operations can be distributed across multiple processing unit. So these are in this way, the parallel processing will support in various units and various type of networks. So, and finally, we have discussed the multi-layer feed-forward neural networks. Excuse me. So we have already discussed multi-layer feed-forward neural networks and also activation function. So most commonly used activation functions sigmoid, tank, relu, and softmax. But we can discuss the multi-layered feed-forward. What is the main use of multi-layer feed-forward networks? Means it is it have the ability to model complex data. That means hidden layers allow multi-layer feed-forward neural networks to learn complex and non-linear relationship. So we can, what is the difference between feed-forward and multi-layer feed-forward? Means it hidden layers allow this type of network to learn a complex and a non-linear relationship. And also next point is versatility. They work for many types of supervised learning tasks, from binary and multi-class classification to regression. So it is mainly supported for a supervised learning task. And also it has a simple structure. The simplicity of a data flow makes them easier to train and compare to network with the feedback loops. So finally, we can say it. We can say the multi-layered feedback neural networks is a neural network with one or more hidden layers that allow it to learn complex mappings between input and output data. It is the foundational neural network architecture widely used for various machine learning tasks. So the components and the structure of uh, all layers will be same only. There is no changes in that. Every neural networks or every type of neural networks having the same structure. That is the input layer, hidden layer, and the output layer. But now we have discussed what is the difference between normal feed-forward neural networks and the multi-layer feed-forward neural networks. Means here the output of the output the feed-forward process is part of a neural network where the data flows from input to output without feedback loops, and also not limited to networks with multiple layers. The main application or where it is used means it is used in both single layer neural networks and the multi-layer networks. That means what is the difference multi-layered feed-forward neural networks is capable of it is mainly used for complex tasks requiring layered feature extraction like image recognition, text classification, and more sophisticated regression tasks. So in this complex task, the multi-layer feedback neural networks will be used. And also the feed-forward process refers to the data flow mechanism. The multi-layer feed-forward refers to the architecture of the networks. So the feed-forward can apply to the single or a multi-layer, but multi-layered, so name itself, it has a multiple layers. So in this, the basic mechanism behind the feed-forward process is found in any type of network without feedback loops. But the multi-layer feed-forward is capable of modeling complex and a non-linear relationship due to the multiple layers. So, and also the main usage is the data movement will be in only one flow. It is the multi-layer feedback is used to describe multi-layer network that applies the feed-forward process. So these are the difference between the feed-forward process and the multi-layered feed-forward neural network. Thank you, professors. Any doubts regarding this session? Professors? Professors? Any doubts? Thank you.
Can ask and they can also use the chat window for asking issues. If you have no doubts, shall we wind up this session here? Okay, I would like to thank Romari ma'am for making this session excellent, and I would like to thank all the participants for attending the session eagerly. Thank you, ma'am. Thank you, all the participants. And all the participants are asked to fill the feedback form